Hello everyone. In this screencast, I'm going to introduce the benchmark plot library that can be used for quickly creating graphs from benchmarks. Let me demonstrate the usage of benchmark plot with a small example. Say we want to create an array which contains all the elements of the original array in adjacent positions. Two very common ways of doing that would be to first use array map and then flatten, or directly use array flat map. Now, if you want to know the time taken by these methods for working on the same array, you'll probably write a benchmarking script which looks something like this, where you send the sizes of your arrays into your benchmarking code, which then prepares the array and performs the benchmarking. The problem with this approach is that it will produce an output which looks like this, which can quickly get out of hand once your number of inputs or the number of benchmarking scripts increase. An obvious solution to this is to plot the benchmarks on a graph, which is where the benchmark plot library comes into the picture. Benchmark plot introduces a single method plot into the benchmark module. The plot method accepts any enumerable object. In this example, I am passing an array of sizes into the method. As you can see, it yields an object in its block, on which you can call the report method. The report method in turn yields the objects inside the object passed to the plot method one by one, each time running the code in the report block and saving the results of the benchmarking for plotting. Running this code will produce a graph which looks something like this. Now, let's take a little more complex example, where we create the arrays before sending them into the actual benchmarking script in the report method, so that the actual creation of the array is not recorded in the benchmarks. For this purpose, let's map array ARR and populate it with sub-arrays of that size. A simple modification to the above script will lead to a script which looks like this. But when you run this code, the output you get ends up looking like this. The reason for this is that the x-axis labels are populated by calling the toS method on the object, which leads to confusion when plotting. To get over this limitation, let's write a simple class that accepts an array object and whose toS methods outputs the size of that array. Let's call this class testArray and design it such that it stores the array in an instance variable called data, and its toS method returns the size of that array. Let's run this code and see the output. As you can see, this is exactly what we needed. In addition to this, the graph that is generated by the plot method can be customized with these options. Title lets you change the heading of the graph. X-labels toggles whether the labels of the x-axis are visible or not. X-axis label lets you pass a string that can act as the label of the x-axis of the graph. Time decides what kind of time is plotted, that is, whether it's system CPU time, user CPU time, or real time. And file name decides the name of the file of the graph. For further information, you can have a look at the benchmark plot repo on GitHub. Thank you so much for seeing this screencast.